Okay, it says trapezoids and kites. We've already talked about trapezoids. We've already talked about kites. So let's, but we're going to learn a little bit more. Okay, that's what we did with, what did we do? Rectangles, rhombus, and squares. Is that correct? We're going to do the same kind of thing with trapezoids and kites. First of all, let's review what a trapezoid is. Just talk about what the definition of a trapezoid is, and then we're going to get a little bit more specific and give you some more details about a trapezoid. So that kind of looks like a trapezoid. If I just drew that picture the way it is right now, could you 100% say that that's trapezoid? No, you could not. Okay, but if I did this, if I said that that is parallel to this, now what can you say about it? Now it's a trapezoid. Okay, a trapezoid has not two, but one pair of opposite parallel sides. Everybody see that? So exactly, that's what the definition said. It says exactly one pair of opposite parallel sides. Does that have exactly one? Yeah, because these are not. If this was parallel to this, then it would be a parallelogram, wouldn't it? Okay, it wouldn't be a trapezoid. But this is a trapezoid. Did we learn anything else? I'm trying to... Yeah, we talked about an isosceles trapezoid. Good. I'm trying to remember what we learned about it so far. So I'm going to try my best. That's pretty close. We did talk about an isosceles trapezoid. So let's talk about that. Again, this is stuff that we've already learned. All right, this is not new. We're going to do the new stuff here in a minute. So, and we are going to talk about an isosceles trapezoid. And we're going to give a little extra stuff. But what do we know about an isosceles trapezoid? Okay, and these two are equal. Right, the non-parallel sides would be equal to each other. That's if this was an isosceles trapezoid. Okay? I think we learned something else about an isosceles trapezoid, didn't we? We call these... Well, these are the legs, and this is the base, so this would be a base angle, and this would be a base angle, okay? What did we learn about the base angles? Well, it's not the opposite angles. It's the base angles are what? They're equal to each other, right? That's on a what? Isosceles. Are the base angles equal to each other on just a normal, everyday trapezoid? No, they're not, okay? So you cannot say that that's true, but if it's isosceles, then you can say these two angles are equal, okay? What else do you think is equal on this? The other base angles, that's right. You got two base angles down here, and you got two base angles up here. Because remember, this is considered a base, and this right here, I'll just write it over top of it, that's also considered a base. You got it? So these two base angles to that same base, these two angles that are formed from that same base are equal, and these two angles up here are equal to each other. So what must be true about this base angle and that base angle right there? Why are they supplementary? Remember, we got parallel lines, right? You got parallel lines. We could consider this to be a transversal, couldn't we? All right. You got it. They're consecutive interior angles. Do you see that? See, these two angles match up with these two angles. We learned this early in the year, that when you have parallel lines cut by transversal, the consecutive interior angles are supplementary. That's a mouthful, isn't it? That's a lot of geometry words that I just threw in there. All right, but that's stuff that should make sense to you now because we've done it so many times. All right, so these two angles are equal, supplementary. So these two angles are supplementary. You got it? That's nothing new. All right, none of that stuff we just talked about is new. That's all old stuff. Now what we're going to do is do some new stuff, all right? And I think we are going to deal completely with isosceles trapezoids. Let me see. Yep, everything that we're going to do today, let me just double check. Well, there's going to be one thing we're going to do. It's not an isosceles trapezoid, okay? But the first part, we're going to deal with isosceles trapezoids. So... let's just start from scratch without all that mess on there, and let's draw another isosceles trapezoid. and let's see what else we can know about it. All right, so I'm trying to push this over a little bit. That's pretty close, I guess. All right, so if that side right there is equal to that side right there, then this is an isosceles trapezoid. All right, so I'll mark it. Those two are equal. This is parallel. So you can look at this 100%. You can be 100% assured that that's an isosceles trapezoid with all that stuff that I put on there, okay? So here's our first theorem. All right, so it's going to just tell you something extra about this that we may not have known before. Oh, you know what? When I just did that base angle thing, I was wondering why some of you guys are looking confused that usually answer pretty well. That is new. This thing that I said right here, that this and this are equal, I don't think we've said that before. That's what we're doing today. I was wondering why I was getting some looks, because Zion usually like, oh yeah, I get that. And I saw in his eyes, he was like, yeah, I'm not sure about this. And the reason he wasn't sure about it, because we haven't done it yet, all right? That's why. So we're going to do it now, all right? So the theorem says that the base angles, sorry about that, I thought that was something, because I've already taught my honors geometry class this stuff, and sometimes I get mixed up on what I did and what I didn't do with you guys and them. So, but this is new. You just heard it. It's pretty easy, but I'm going to write it down. The base angles of an isosceles trapezoid. What do you think? We just discussed it a second ago. So what's true about the base angles? They're equal. That's good. Okay. The book uses congruent. That's fine. It's probably preferred, but I like to say equal sometimes. And there you go. So there's your theorem. The base angles of an isosceles trapezoid are congruent. So I could come over here and mark them. So let's say let's use the letters I used in my notes. K, and then this is J, this is I, and this is H. Okay? All right, so what does this theorem tell us? This theorem tells us that angle H equals what? Which angle? Angle I, good. And what else is equal? Angle K and angle J. All right. Everybody good with that? Yeah. All right, here's another thing. Do you remember that? Do you remember we had a whole section where we said, okay, if this is a parallelogram, then the opposite sides are equal. Then we had another lesson that said, okay, if you have a four-sided figure, quadrilateral, and if both pairs of opposite sides are equal, then it's a what? It's a parallelogram. That's what we're doing right here. If you have a trapezoid, right, pretend this. Pretend you did not know that that side was equal to this side. Okay? So this is a little different than what we did before, just a little bit different. So if I give you a trapezoid and I give you this information right here, what can you then say about this trapezoid? If the base angles are equal to each other, right here, if these two are equal and if these two are equal, what kind of trapezoid would this be? It would be an isosceles trapezoid. You see that? You see the difference? The first time we said, okay, if you have an isosceles trapezoid, then what's true about the base angles? They're equal. This one says, it's kind of like the opposite. They call it a converse, the converse of this theorem, which means you switch the if and the then. The first one says, if you have an isosceles trapezoid, then the base angles are equal. Do you see that? Okay, if the base angles are equal, I could have done that. Let's do that. Okay, what was the first one say? If you have a what? Isosceles, I'll just shorten, oops. Yeah, let's do this. It looks like a frap, doesn't it? Let's make this look a little nicer. All right, so if you have an isosceles trapezoid, then the two sides are equal, correct? I'll just shorten it, okay? So if you have an isosceles trapezoid, I'm sorry. I'm not thinking straight. If you have an isosceles trapezoid, then the what? The base angles are equal, okay? Now watch this. Do you see where the if is and the then? Okay. Let's switch it up. So if the base angles are equal, then what do you have? Right, that's it. Then it's an isosceles trapezoid. See the difference? Okay. Our writing's terrible today, but you get the idea. It's actually not very good any day, but that's okay. So that's what we're doing. Okay, it's similar, but a little different. Yes. All right. Enough of that. So let's go back up to this. Let's just write some stuff down so you can see it very easily in your notes. You see that these are equal, but let's write it down. So what? And you've already said it once, but angle H would equal what? Angle I, and then what else? Angle K equals angle J. All right. So if it's an isosceles trapezoid, then the base angles are equal. If the base angles are equal, then it's an isosceles trapezoid. All right. It goes both ways. All right. Enough of that. Let's do another isosceles trapezoid. Oh yeah, I'll just copy this. And we're going to put some diagonals in here this time. I don't think we've done that, have we, with an isosceles trapezoid? Can't remember. All right, so let's get rid of this stuff. I don't really need this for what we're going to do right now. I do need to put those little arcs there. What are those little tick marks? What do those little tick marks tell you? That they're equal, and so if they're equal, then this is a isosceles trapezoid. Good. All right, so we have an isosceles trapezoid. What we're going to do now is we're going to put some diagonals. There isn't much to this. I bet you could probably guess what's true about those diagonals without me even telling you. What do you think? What do you think's true about Ki and JH? They're equal to each other. Exactly right. Now, that's only true when you have a what kind of trapezoid? Isosceles. Okay, if you have a normal everyday trapezoid and these two sides are not equal to each other, then those diagonals are not going to equal each other. All right, let's go back to that first trapezoid that I drew right there. See, that's not isosceles. Would you agree? So if I drew a diagonal here and I drew a diagonal here, are they equal to each other? No, they're not. Okay? Everybody see that? So when you just have a normal everyday trapezoid, the diagonals are not equal to each other. But when you have an isosceles trapezoid, then they are equal to each other. So just like on that last one, let's write down some stuff. So what did I say? Ki equals, this is I. Did I? No, I think, yeah. See, I had a K and an I. It's the same thing. So Ki is equal to what? JH. Everybody got that? All right. Now, do they bisect each other or anything like that? No, they don't. Not on a trapezoid. So don't fall into that trap, okay? They only do that when it's a parallelogram. Remember that? So if it's a parallelogram, they bisect each other. On a trapezoid, they do not. All right, let's do an example. How about that? Let me just erase this. Let's put some stuff in here, and let's see what we can do with this. So they tell you, here's the stuff that they tell you. This is given, right? When they use the word given, that means this is what they're telling you is true. So they're telling you that an angle, ABC, is equal to 125 degrees. They tell you that line segment AC is equal to 7x. There's no degrees there because this is a line segment, okay? And they also tell you that line segment BD is equal to 4x plus 12. All right, so that's all the stuff that they give you. Then they're going to ask you to find a bunch of stuff. Let's do that in a different color. Let's do it down here. So I'm going to ask you to find 1, 2, 3, 4, 5, 6 different things. Okay, you're going to find angle BAD. You're going to find angle ADC. For a shout out? Oh, a shadow. I thought you said for a shout out. All right, and then angle ABD. All right, and you got more stuff. How in the world could they ask you for that much stuff? Angle ACD. Angle AED. And one more, they ask you for line segment AC. All right. Well, where do we begin? Let's go back to yellow. Let's put the stuff in here that we know, all right? And in fact, I'm not even going to put in that AC and BD because you only have one question where you're trying to find the length of a side. Let's just deal with the angles right now. So angle A, oh, I guess I could have marked it right, couldn't I? There's no AB, CD in here, so let's mark this correctly. ABCD, A, B, C, D. There we go. And they call this one in the middle, they call it E. All right, so that point where they intersect is point E. I think they tell you one more thing. Yeah, they do. I didn't mark that in my... I just marked it on the picture. I should have written it down here. They say that this little angle right here is 30 degrees. And I think that's everything. All right, so we basically want to find all the other angles. All right, so let's see. Let's start with BAD first. All right, so BAD. What angle is angle BAD? It's that big old angle right there. All right. Well, let's write some other stuff. ABC. Where's ABC? ABC is this angle right here. What is ABC? It's 125. I'll just put a little arrow there instead of messing it up inside there. So look, the angle on the left, that yellow angle on the left, should be really easy to find now without any math at all. So what is angle A going to be? Look, they tell you this one right here is 125. We just learned something. Say it. Say it. I don't know what you're saying. He said 30. He said this is 30 right here. Look at it. Okay. It's 125. Why? We just learned it. What did we learn? That the base angles are what? Equal to each other. So if I know this angle right here, then what's this angle right here going to be? The same thing, right? So if this is 125, what's that going to be? Isn't that the same thing that's going on right here? Yeah, that whole angle is 125. So that whole angle is 125. All right? So that is 125. Oh, why did I gave an answer here. Well, that was dumb. I'm looking at my answers and I wrote equals 55. But anyway, we got to find it. So I kind of gave it away, this next one. So let's find it. ADC. Where's ADC? That's this whole big angle right here. I'll put a double arc on that. We got to find that whole entire thing right there. So remember, this angle right here was what? 125. So it's 125. So watch this. If I want to find that whole big angle, what is it? Say it, Sincere. You said it. You got it. 180 minus 125. Why? Because these two angles, see that big angle A and that big angle D right there? They're what? Give me the word, geometry word. They're supplementary to each other, okay? So if they're supplementary, they add up to 180. So in order to find that whole big angle right there, I go 180 minus 125, which is 55. And that's why I wrote 55 earlier. That was a mistake. Make sense? All right, that's not so bad, right? We've done this stuff before, this kind of stuff. We just haven't done it with an isosceles trapezoid. That's the only thing different about this, all right? But the style of problem we've done several times. Can somebody get the door, please? ABD, where's the ABD? Let's do a different color. There's too much yellow in there now. Let's go this pink color. Where's ABD? That's this one. I'll just do it in pink. There's that little tiny one right there. So what's that? Everybody look at it. See that little pink one that I just drew right there? Can you tell the difference between the pink and the red? So this little angle right here, this little one right here, what do you think? Why? You are right. It is 30. So that angle is 30 degrees. Sincere, why? Why? Why is it equal? That's the question. We talked about this before, Abdul. Say it. Alternate interior angles. That's right. You got it. Okay. Remember we talked about that like 2 days ago? Yep. Alternate interior angles. Okay. So that's exactly right. What's going on here? Look, I got a parallel line, and this BD right here is my transversal, isn't it? Where's the 30? It's that angle right there. Where's this 30 right here? That's this one right here. Do you see how they're alternate interior angles? So you got to look for that. You got parallel lines, you got transversals. You got to go back to that stuff we learned a long time ago. If you probably won't do this, but if you ever go back to one of the videos when we taught this, most likely, I don't know 100%, but most likely I probably said at some point that this is not the only place you're going to see this. Later on in the book, you're going to be using this over and over again. Was I right? If I said that, I'm pretty sure I said that. All right, I usually do. Yeah, absolutely, because you use that quite a bit. All right, so that's 30 degrees. So that was easy. Didn't have to do any math at all with that, did we? Everybody good? All right, what's this? ACD. Where's that? ACD. That's this little one right here. I'm trying to think of a good... It would be 30 again. No. What was the 55? The 55 was this whole big thing right here. I'm trying to think of a good reason. I mean, this big angle D would be equal to this big angle C right here, wouldn't it? Okay. Let me think. Trying to think of a good reason, because we had a reason for that one. It is 30. That is true. Because do you see how this diagonal and this diagonal are going at the same angle? All right. So this one and this one be equal to each other. Because I don't think we had anything that said that this was equal to this. But if you did, you got a triangle, right? This triangle right here. If these two are equal, then these two angles right here are equal. So I don't have a really great reason for that, but it is 30 degrees. I wish somebody would raise their hand and I say yes, and they have like a really good question about what we're talking about instead of going to the bathroom every time. If I had a nickel for every time I signed a bathroom pass, I'd be a rich man right now. All right, here we go. Let's do ACD. So we got ABD. Where's ACD? Oh, we just did that. That's 30 degrees. We just did that one. That's this one right here. All right, one more angle. AED. Where's that? A, E, and D. So let's change colors with this one. So that's that angle right there. So what do you do? You could do this. Watch. You could do a couple things. This is a little obscure. Ben, are you going to pay attention? You're just going to worry about making people laugh and making dumb noises. Okay, because if this choice is second, you can just go. But if you're going to pay attention, then just sit there and watch. Quit trying to make people laugh all the time. It's not that funny. So look, we're trying to find this angle right here. I don't know if you remember, but do you remember you had this triangle? Remember this exterior angle is equal to the sum of the remote interior angles? You actually have that here. Because look, let's look at this triangle right here. You see this? See this big triangle in the middle, down the bottom right there? So this is an exterior angle to this triangle, isn't it? And this is a remote interior angle. This is a remote interior angle. So I could just go 30 plus 30 is 60. Or you could do this. If this is 30 and this is 30, that's 60. What's this big angle right here? That'd be 120. Because 180 minus 60 is 120. And then I could do what? This whole line segment is 180. So what's 180 minus 120? It's 60. But that's like two things you got to think of, right? If you can remember this thing right here, that exterior angle, then you could just look at this, add these two up, and bang, that's your angle right there. Again, this is something we did a little while back, right? That's coming back, right, to use again. That's why it's important to remember that old stuff that we learned. But you could look at it a couple different ways. All right, so we did all the angles. That's pretty much every single angle in here. All right, let's do AC. Where is AC? That's this whole line segment right there. All right, I'll tell you what. Let's just change colors just to make it pop a little bit more. So the green one, okay, that's what we're trying to find. We're trying to find the length of that green one. Well, what do they tell you? They tell you AC is 70 or 7x. They tell you that BD, which is this red one, okay, is 4x plus 12. I'm not going to write it all in there just because I got too much junk flying around. But what's true about that red one and the green one? Or they were both red in this. Here, let's just make them both red. All right. Supplementary, they're line segments. Line segments can't be supplementary. Don't just throw out geometry words just because you think it sounds smart or something. What's true? I heard it. They're congruent to each other. That's right. Okay, those two diagonals are congruent to each other. How do we know that? Did I have it here? Oh, it's because I used this to show the congruent triangles and I didn't make a new one, right? We just talked about it, right? We said that the diagonals of an isosceles trapezoid are congruent. So they are equal. So how does that help me? How does that help me with this? What's true about AC and BD? They're what? They're equal to each other, correct? All right, so what do I do with that 7x and that 4x plus 12? Set them equal. Good. I like that. You're finally getting the hang of it, all right? Set them equal. So here we go. 7x equals 4x plus 12. Now the math is super easy. You might even be able to do that whole thing in your head. I don't know. But let's show the steps. Minus 4x minus 4x. 3x equals 12. What's x? X equals 4. But is that what AC is equal to? No. We got to plug it in. Plug it in for that. So it's 7 times what? 4, which is 28. So what's AC? It's 28. Is it 28 degrees? No, because it's not an angle, is it? Look at all the other things. If you look at your quizzes, so many quizzes, I had to put a little degree symbol, all right? Make sure, if it's an angle, if you're solving for an angle, what should your number be? It should be in what? Degrees, okay? You should do that every single time. I know teachers that will mark the problem wrong if you don't put it in degrees. I'm really, really tempted to do that, all right? Because it happens so much. It's just laziness, all right? If it's an angle, it's in degrees. If it's a line segment, this is a line segment. It is not in degrees. It's just a number, okay? Make sense? Another bathroom pass. How much money am I up to yet? I said a nickel a bathroom pass. That tells you how old I am when I say a nickel. You guys even know what a nickel is? Okay, good. All right, look at that. Look how nice and colorful that is. Isn't that pretty? Yeah. Yep. All right, sure. All right, let's do one more thing with a trapezoid. I'm going to save kites till tomorrow, okay? So we'll just finish up the trapezoid stuff today. So now what I'm going to do is I'm going to draw another trapezoid. It doesn't necessarily have to be isosceles this time, all right? So here's something that's a little different. So let me just draw a parallel line here, parallel line right there. Tell you what, I'll just scooch this over a little bit. I just want to make it obvious that it's not isosceles, okay? Whew, that's a pretty big trapezoid, isn't it? Now, watch what I'm going to do. What I'm going to do is I'm going to grab this. Do you see that little blue? It's kind of small. Do you see that little blue dot? This program actually shows where the midpoint is, all right? So if I'm going to put a little dot at this midpoint, then I'm going to come over here to this one. I'm going to find the midpoint of that one, which is right there. Everybody see that dot? All right, and then right there. Now what I'm going to do is I'm going to connect those two midpoints to each other. Okay? Everybody see that? All right. Let's label some stuff first. And then we're going to talk. There's going to be two things. I bet you anything that you could figure out what the one thing's going to be. That red line compared to the top and the bottom. What do you think might be true about it? Just off the top of your head, what does it look like? That red one compared to this one and this one. It's parallel. Very good. Okay? Yeah, it will be. Okay? And that's the first thing that we're going to talk about today, that they are parallel to each other. Let me label this A, B, C, and D. We'll call this M and N, these two midpoints. Remember, this is a midpoint, so that means that and that are equal, and this one and this one are equal. Does that mean it's isosceles? No, because that whole thing is not equal to this whole thing. But these two parts are, and these two parts are, because M's a midpoint and N is the midpoint. Everybody see that? What we're going to do right here only works when M and N are the midpoints. What do we call the top and bottom? We call these legs over here. What do we call the top and the bottom? We call them bases, okay? It doesn't matter which. So let's call this base 1. So I'll call it B1. What do you think I'm going to call this one up at the top? Base 2. Very good. All right, so I'm going to call that base 2. All right, there's two bases, and they're different lengths, aren't they? That's why I called one base 1 and base 2. That's why I can't just call it the base, all right, because they're two completely different lengths. Everybody with me? Now, there's two things that are true about that. What's the first thing that you said was true about this? Oh, by the way, they're parallel. That's right. By the way, I almost forgot. They give this a name. That red line right there, they call this the mid-segment. Did we do mid-segment earlier with the triangle? I think we did. I can't remember if it was this class or the honors class. I think it was you guys. Yeah, we did mid-segment. So this is kind of the same thing. Kind of. All right? It's the same thing. If you remember, watch. Let's just go back in time a little bit. If I found the mid-segment, it was from here to here. It was parallel to the base. This time, triangle only has one base. But it was also equal to what? So like if that was 8, what's the length of this little bit right here? It was 4. Agreed? You remember that? Yeah, it's been a while. We haven't talked about that in a long time. But we did do that. And we also said it was parallel, okay? This is kind of the same thing. Kind of the same thing. First of all, this is parallel to the other one. So I could say that MN is parallel, that's supposed to be an N, is parallel to what? AB. And it's also parallel to what else? This red one is parallel to AB, and it's also parallel to, come on, DC, right, okay? Or CD, doesn't make any difference. So that's the first thing that we know about it. Here's the second thing. The second thing is very similar to what we did when we did a triangle, okay? But this isn't half of base 1, and it's not half of base 2. It's definitely not half of base 2 because it's bigger than base 2, isn't it? All right? And this, it's actually almost the same length as base 1, right? But check this out. If I added up base 1 and base 2, all right? So the mid-segment, I'll just write it down here. The mid-segment is equal to half of the two bases added together. Everybody hear that? So if I added up the two bases and I took half of it, that's going to be the length of this mid-segment. So that's why I called this base 1 and base 2. That looks a little confusing, but it's actually pretty simple. It's kind of like finding the average. So if I had two things and I wanted you to find the average between those, what would you do? If I had two numbers, 3 and 5, how would you find the average of 3 and 5? No, you don't subtract. Finding the average? Just finding the average of two numbers. Let's say I had 3 and then I had 5. I got 3, and I got 5. What's the average between those? You don't know how to find average? Yeah, add them up. It is 4. Yeah, add them up, and then do what? Divided by 2. That's what you're doing here. So the mid segment, if you want to think of it this way, I don't think the book ever says this, but this is what goes through my mind. The mid segment is kind of like the average between the two bases. So what do you do to the two bases? You add them up, right? Base 1 plus base 2, and then do what? Divide it by 2, or take half of it. Everybody hear me on that? Okay, so for instance, if this was 10 and this was 4, okay, what would the mid segment be? It'd be 7. It'd be that easy. You watching? So what was the math? It was 10 plus 4, and then what? Divided by 2. 14 divided by 2 is 7. So the mid segment is 7. So the length of that would be 7. Now watch this. Since it's the average, look, it's the same distance to here. How far is it from the mid segment up to here? It's 3. How far is it from here to here? It's 3. Do you see it? So it's right in the middle. Make sense? Yeah, the numbers all work out. Everything's good. All right? Now, you know what they're going to do, right? They're not just going to give you a 10 and a 4. What are they going to put in there? Something X, exactly. Something X. So let's do this. I'll tell you what. Let's just, instead of redrawing the whole thing, let's just get rid of all this mess. And then we'll just use the same picture. They actually use the same picture, but they kind of flip it upside down. All right, so they have that little one on the bottom and the big one on the top. That's in the book. If you want to look at it, it's fine, but this will still work. All right, so the longer one, they call it 4x plus, they used R, but I'll use X. 4x plus 2, and this one is 2x, and this one is 10. Now look, the math on this is a little bit more involved, just a little bit. But let's go through how we found it. That MN, okay, look, let's use this thing right here. Everybody see that? Okay, so do I know MN? Yeah, I do now, don't I? I'm not just trying to find it. They actually tell it to me. They say MN is what? Is 10. So I'm using this little formula right here. Everybody got that? So I'm going 10 equals, and then we're going to put a 1/2, and then what are we going to do to the two bases? 4, yeah, we're going to add them up. So let's go 4x plus 2. That's the one base. Add it to the other base. And now what we're going to do is we are going to just solve for x. So let's do it. 10 equals 1/2 of, what do we got here? 4x plus 2x is 6x plus 2. Now let me show you a little math trick. I don't think we've done that in here. I think maybe we did at the beginning when we first did that algebra stuff. How do I get rid of a fraction that's being multiplied? I multiply by the reciprocal. Okay? All right? So I got a 1/2. How do I get rid of it? I multiply by 2. So what do I do over here then? Multiply by 2. What happens? 2's cancel, 1's cancel. I got rid of that half, didn't I? All right, so what do I got here? 2 times 10 is 20 equals, what's this? 6x plus 2. Now, that looks a little more normal, doesn't it? So now I can subtract 2 from both sides. I got 18 equals 6x. Do what to get x by itself? Divide by 6. So x is what? 3. Is that my answer, though? No, they want you to find these two. Right, they want you to plug them in. So what do we say? X is 3. So what's the top going to give us? 2 times 3 is 6. And then put a 3 in for this. 4 times 3 is 12 plus 2 is 14. Now, let's just double check. Remember we said this has to be the same distance away as this does? Is it? Yeah. From 10 to 6 is 4. From 10 to 14 is 4. So we did it right. What do you think? I went a little fast because I was trying to race the clock a little bit and get that, but that's what you want to do. All right? The math was a little bit more involved. It was kind of weird, but this is the formula right here. You could write that formula another way. You could have written it like Mn equals B1 plus B2 over 2. Isn't that the same exact thing? Dividing by 2, multiplying by a half. So however you want to write it, that's how you write it. And again, this is basically the average. It's the average of the two lengths. All right. I did not write down. Hold on. Don't leave. Don't get up. Have a seat. We're not finished. Let me see the homework. I think I did split it up. Yeah, I did. Okay, so you're only doing 1 through 12. We're not doing the whole thing today. I'm going to finish up tomorrow, do some kites. So I believe you should be able to do all of these. So you're doing 1 through 12, and it's section 6.5a. 6.5a. All right, and it's page 280. You should be able to find it anyway just by knowing the section. Now look, I'm having some sincere doubts on how hard or how much effort that many of you, not all, okay, some of you, I can tell you're putting a lot of good effort into it. Some of you guys, I mean, I'm giving you the points for the homework for completion because I don't know what went behind the scenes. I don't know. But I can almost, and if you're honest with me, you probably agree with me, many of these homeworks are just turned in and you're just writing down stuff. I mean, I don't know how much effort you're really putting into it. I don't think much. Okay, I'll be honest with you. Okay, I'm not accusing any one particular person, but this is a time where you got to put some effort into it. Put some effort into your homeworks. This is where you learn the stuff, okay? This is how you learn, by putting effort into your homework. All right, we'll see you.